How we doing, folks? So we're on to chapter 5, decision structures. This chapter, like the previous chapter in this presentation video, I will be embedding 3 questions that you need to answer in a Word doc just to make sure everyone's watching the presentation all the way through. The chapter 4 video, I had a lot of hits. It looked like everyone watched it. Most people answered the questions, so that's good. That's what I'm looking for. So we'll continue that with this chapter. So make sure you're watching all the way through. Answer those questions in a Word in a Google Doc for me. So chapter 5, the big new topic in this chapter is decision structures, which is basically if-then-else statements. So our applications are going to get more complicated. We'll be able to make decisions with our applications. But in addition, our applications will get to the point where you cannot crash them. So you may have noticed in the last chapter, if you entered some data that the application wasn't expecting, like in the bike application, if you entered a G rather than a number in the text box and you hit calculate, it would crash because what you were doing is you were trying to convert a letter or a string character into an integer, and you can't do that. The application just crashed. And there's many ways that you could crash those applications. You may have found that yourself, or I may have showed you that when I tested your application. And that was fine for chapter 4 because we didn't have the skills or the ability to fix that. This chapter, what I'm going to be looking for is applications that you cannot crash. So no matter what we put into these applications, they will not cause errors. And ultimately, that's where we want to go. That's difficult to do. So it'll take a little bit of work to get there. We won't be completely there with that chapter, but we want to get as close as possible. So that's kind of the gist of chapter 5. So 3 new objects that we're going to be introducing in this chapter: the GroupBox Object, the RadioButton Object, and the Message Box Object. We are going to be continue using labels and text boxes and some of the other stuff. We've been using picture boxes, but these are the 3 new additions that we're going to be using in this chapter. Every chapter in this book, we introduce a couple new objects that you use to make your user experiences more rich. So like I said before, the big thing is making decisions using if-then statements. We get a little more complicated using if-then-else statements. And we can also nest our if statements. So put an if statement inside an if statement. And you can go many, many different nesting levels for that. We'll get into that. We'll talk about making decisions with logical operators. Okay, and we'll talk about using case statements. A case statement is just a different way to write an if-then-else statement, a little cleaner for certain scenarios. We'll talk about testing input to ensure a value is numeric, and bulletproof applications. And those 2 things kind of go hand in hand. Like I said before, with this chapter, our applications are going to get a lot cleaner, and we're going to do a lot of checking and validating to make sure that whatever the user puts into that text box when you click calculate, the application does not crash. And when I test your applications in this chapter, I will be trying to crash them. And I know lots of ways to crash these applications, probably a few ways that you guys won't think of. So that's going to be a little fun thing that we do this chapter. You're going to try to make applications that I can't crash, and I'm going to try to crash your applications. So we'll see if anyone can create an application that I cannot crash. It's tough to do, but it has been done before. All right, so the 3 new objects in this chapter: GroupBox, radio buttons, and message boxes. So the application, the guided program walkthrough, is a decking cost calculator, and we'll talk a little bit about that in the next couple slides, how that works. Still pretty simple application, but a little more complexity than the cases in the previous chapter. All right, so the GroupBox object. The GroupBox object isn't like a lot of the other objects that we've used. It's really just for organizing things. So this box right here is our group box, and it's used for grouping things together. So in this case, we'll be grouping radio buttons together. So like I said, just for organization, keeping things grouped together, put a label on it. It's really just a UI thing, nothing more than that. And it's in the category of container objects. So there's different types of container objects. There's tabbed containers, there's panel containers, there's GroupBox containers. There's a couple types of containers that you use in different scenarios. But a GroupBox is pretty much a classic UI tool that you'll be using. So this is what ultimately what your chapter walkthrough application is going to look like. It's a decking cost calculator. You'll be putting in a square footage, and then the users will be selecting in these radio buttons here, and the radio buttons are in a group box, a type of wood. And each type of this wood has a different cost. So that you're going to, calculate 100 square footage, and the pressure treated lumber is, $10 a foot. Redwood is $15 a foot, and composite is $25 a foot. So then the calculation will happen based on the square footage, and there'll be a different cost associated with each one of these. And as you can imagine, you're going to use an if statement depending on which one of these was selected to calculate the final cost. Pretty simple, not too big, not too big a deal. So these are our radio buttons. So that's our second object. And the reason I call them radio buttons, it's kind of an odd little thing that you guys may not even have ever been exposed to, but back in the 1970s and 1980s, we had car radios that had buttons on them for presetting the stations. And when you pushed one button, the other button would pop out. So only one of those buttons could be selected at a time. Those were radio buttons. And that's kind of how these radio buttons work. You can only select one of these buttons at the same time. So if I select redwood, pressure treated lumber is going to become unselected, just like those radios would be selected. Now, if you had an application where you wanted all three of them or a multiple to be selected at the same time, you'd use a checkbox object. But if you only want one selected at a time, you use radio buttons. So that's our second new control or object that we're going to be introducing in this chapter, radio buttons. And we'll dig much more into those when we start, when I go through the guided program walkthrough. I'll show you how to add them, how to do naming conventions and all that. So radio buttons have a checked property. So they have a text property, they have a name you'll give them, but the check property is true or false depending on whether that particular radio button is selected. So that's just something to be aware of. So only one of those can have, one of the radio buttons in the group box can have a checked property of true. Otherwise, you'll run into some issues. So like I said, the group box is a type of container object, and there are multiple types of container objects that you can have in your application. The other type that is available to you is a panel object. Now, there's a couple differences in a group box and a panel object. The group box object has more options. So a group box object can have a caption. It can have scroll bars if you need. So if you have a lot of radio buttons in a group box and you want to be able to scroll through them but not have them all be displayed on the screen, you can do that with a group box, but you can't do that with a panel object. Panel object is just a simple box. And a group box object can have a displayed border and a panel object cannot. So a group box object just has a few more options for them. And again, those are both container objects, which probably won't be listed under common controls. I'll show you how to get to it when we do the guided program walkthrough. So this is just an example of what a group box object looks like and a panel object looks like. You can see the group box object has a caption, and the panel object, you will have no property to put a caption in there. So question one. So this is what you're going to need to answer for me. That's my embedded questions in this presentation. What is the difference, or what are the two types of container objects that we talked about in this presentation? Okay, just talked about them. So what are the two types of container objects that I talked about in this presentation? Question one. So the final new object that we're going to be working with in this chapter is a message box. And a message box isn't a control that you're going to be dragging in from the toolbox like some of the other controls, like the GroupBox and the radio button. The message box is controlled entirely through code, okay? So why we use message boxes is to make the user's experience richer. So in this application, or in this chapter, we're going to be trying to prevent the users from creating errors by entering invalid input. So for instance, if the user brings up this application and just hits calculate without entering any square footage value, that will cause an error because the value that they're entering is not numeric, it's not a value, and you can't calculate nothing to a number. So that would cause an error. So you don't want the application to just crash. What you want is you want to display some feedback to the user and tell them what they did wrong and tell them what they need to do to create it. So in this instance, the user entered nothing, hit calculate, and the message box popped up that said enter the square footage of decking. Okay, just a simple message to let the user know what they did wrong and what they need to do to correct it. So in this instance, we have another message box displaying the user entered a negative number. So we cannot buy negative square foot of decking or wood. So we display you entered -6, please enter a positive number. So our message box is telling them what they did wrong and what they need to do to correct it, okay? So it should be pretty straightforward, but you'd be surprised what users try to do with applications. Sometimes users are doing these things by accident. Sometimes they're just trying to see what they can do to make the application crash. And sometimes if you're using applications that are visible to the public, not an internal application of the company, you have users trying to hack the applications. Many different ways you can hack applications. And when you're building applications for the public, you have to be very careful of users doing things like SQL injection queries to try to access the code or access the database. So it becomes even more important to make sure that user is entering only valid data. All right, so to display a message box, the simplest, so message boxes can be very simple or they can be, there's lots of options, they can be very complicated. So the simplest way to display a message box is just in your code type MSG-BOX in parentheses and then the message in quotes and parentheses. And that'll display enter the square footage of decking. So whatever you put in this message is going to display in the middle of the message box, and you'll just have an OK button. So just a brief, simple message to the user, they click OK, and they move on with the application. So depending on where you put that message box, maybe the application closes, maybe it just moves on in the code, depends. That's what you have to decide in your application, what you want to have happen after they select OK with the message box. So message boxes have 3 arguments in them. So here we see notice the 2 commas between the 2 arguments. So when we see 2 commas, that means there's a space here for a second argument that we're not using. So the first argument is the message. That's what's displayed here, enter the square footage of decking. We're not using the second argument here because we have nothing between the 2 commas. And then the third argument is enter missing error. Oh, error. Missing a number. That should actually be up here in the caption. It shouldn't be input error. There's just a little mistake on the slide. But this last argument is the caption that displays at the top of the message box. So a message box can be displayed during execution with a variety of arguments. In many applications, the caption is used to give further information to the user. So you want to customize those message boxes so they're as friendly or as usable to the users as possible. So a couple additional things we can do to customize our message boxes is we can use that second argument as a button entry. So there's different message box styles. So in this first example, we're using a message box style of OK cancel as our second argument. And it doesn't just display the OK button, we have an OK and cancel button. And you can associate code with these buttons or do different things if the user selects OK or cancel. So this one is message box style retry cancel. So this retry button is displayed and the cancel button is displayed. So again, you can do different things depending on what the user selects for retry or cancel. We're not going to do anything like that in this chapter. We're just going to be pretty much using the OK. But it's good to know that these options exist if we ever need to use them in the future. So these are all the different message box styles that you can use. So we have OK only, which is default if you don't display that second argument. We have OK cancels, abort, retry, ignore, yes, no, cancel, yes or no, and retry and cancel. So lots of different options for the buttons you can display on your message boxes. And we also have icons we can display. So you can use message box style critical, which will display a little X here, or message box style question, that's going to display a question mark. So lots of different ways to customize these message boxes to make that user experience a little more useful for the user. And these are kind of all the different icons you can use. So we have the critical with the X, question mark, exclamation, and information. So might be something you want to use in your application just to give the user a little more feedback. So we will be using concatenation in our message boxes in some cases in this chapter. So in this example that we showed before, the message box is displaying you entered -6, and we're actually grabbing that -6 from the text box and concatenating some text onto it. So our message box says you entered, and then we concatenate the value in the decimal footage text box, which has been converted to a variable here. We can concatenate a period and then tell them to enter the positive number. So we're taking the number that they entered that is incorrect. So the message box goes into an if statement, and we've looked at the value and determined that it's negative. So we're going to be using if statements to do that. And the message box just does a little concatenation. And we'll show you how to do this in code in the guided program development. So a decision structure is one of the 3 fundamental control structures used in computer programming. So the first control structure we've been using all along, it's just sequential control. That's when your application goes top down. Decision structure is when we're jumping through if then else statements. And the third decision structure we'll use is loops, which we'll get into in the next chapter. So we'll be covering all the decision structures very shortly. When a condition is tested in Visual Basic, the condition is either true or false. So with our if statements, we're looking at something. So if something, if this value is equal to this value, so if that is true, then we do something. Otherwise, we do something else, or we do nothing. Depends on how you write that if statement. So a simple if statement, and you've probably all been exposed to if statements in some way, probably last year in your AP course with Mr. McNeil. So you should have some general idea of the logic in it. So in its simplest form, if a condition is true, then we do something. So the condition portion of the if statement means the condition is tested to determine if it's true or false. The condition can be tested as follows. So You can check if one value is equal to another value, a value is not equal to another value is greater than another value, less than another value, greater than equal, or less than or equal to. So those are all our basic kind of logical comparisons or relations that we can use in our if statements to determine if something is true or false. And that's, when you think of programming, that's a lot of what we do. So these are the symbols that we use for relational operators. So we have the equal for equal to. Not equal to is the left caret, and they call these carets, I guess, or less than and greater than. So that's on the bottom row of your keyboard above the comma and the period. So not equal to is those two symbols, the greater than and the less than, and then we have greater than, less than, we have greater than and equal to, and less than or equal to. So in this example, we can say if the value in my int age variable is greater than or equal to 18, then we put you are old enough to vote in this label's text value. Pretty simple. If they're not greater than 18, what do? We do nothing. There's no logic for that in this portion of code that we have. So another example to compare two strings. So these two strings are A, B, and C. So we say if string 1 is equal to string 2, then we put equal in label string text, the text value of label string text. If we change one of these to A, B, C, D, E, then nothing happens. It'll evaluate this, it will never hit this piece of code, it'll jump right over it. So every type of data available in Visual Basic can be compared. So different number types can be compared to each other. A single string character can be compared to a character data type. VB will allow you to compare strings to numbers, but you want to avoid that because oftentimes it will give you results that you don't expect because it tries to do some implicit conversions itself in the background and it won't always turn out the way you expect. So if you want to compare things, try to convert them to the same or similar data types. So stick with comparing numbers, stick with comparing strings and characters. Integers and decimals are fine to compare, but you don't want to compare a string to a decimal or a character to an integer. So stick with the same family of data types when you're doing your comparisons. And you probably won't have to worry about that much in this chapter, but going forward, we'll get to some more advanced stuff where you may run into that. So the next level of complexity with if statements is if then else statements. So this we have different conditions. So if this condition is true, we do something else. So if that condition is not true, we do something else. So in this example, if student status is equal to graduate, then we calculate the student's fees as graduate fees times number of units. If they're not graduate, so our else, then our student fees are undergraduate fee times number of units. So just a little different calculation depending on whether they're graduate or not. So in this example, they're either, if they're not graduate, then they are undergraduate. There's no option for anything else, which probably isn't great code because there's probably other things other than undergraduate that you could put in there and it would calculate them as undergraduate. So not the best example, but it works for this scenario. You can also compare complex arithmetic operations. So in this example, we're saying if desk withdrawals is greater than the current balance plus deposits minus desk account charges, then we display our account status as overdrawn. Otherwise, we display our account status as balance is positive. You can do this. I wouldn't recommend doing this. What I would do in this example is I would do this calculation first above the if statement and just use, like, put these three values in a variable and compare these to one variable rather than this, because this is kind of complicated to do within an if statement. And it kind of slows the if statement down too. It's okay, VB will allow you to do it. I just think it's not the cleanest way to do that. I would do this calculation above, outside the if statement, rather than doing it as part of the statement. But you can do it. VB will allow it, just not the best way of doing things. Most programming languages will allow you to do a lot of things that you probably shouldn't do. And that's where becoming an experienced developer and running into things that cause problems, you start to realize the way you shouldn't do things. And that's what I'm here for, to help you out with stuff like that. When I see you doing something that may cause a problem later on, I'll point it out to you. And you're going to do these things when you're an introductory developer, and that's just fine. So we also have what's called trailing else statements. So in this example, we have if the age is greater than or equal to 65, then we give them full benefits. Else if the age is greater than 0, they're not eligible for benefits. And then we have a catch-all at the end, an else. So this is anything else if they're less than 65 and or not greater than or equal to 65 and not greater than 0, then they've entered an invalid age. So if the age is negative, or the age is I guess you can't really have anything else other than an integer, but this is just kind of your catch-all for invalid ages. All right. The next level of complexity we have is nested if statements. And all a nested if statement is an if statement within an if statement. And we can nest things in our applications to multiple levels. And I think in our guided program development, we're going to have at least 3 levels of nesting with all our validation that's going on. And what's going to help you with nested if statements is your indentation. So Visual Basic will do this indentation for you, and indenting your code makes it much easier to read, especially as you have multiple levels of nesting. So you're going to have, an outer if, an inner if, and you might have if statements inside these if statements, okay? So when you're doing that, indentation is going to help you follow what's going on. And the GUI has some nice tools to help you line things up. And this is where students tend to get themselves into a little trouble when they don't end the if statement properly and put this end if down here, and things get all mixed up. So it's really important to indent things and keep things organized when you're working on these if then else statements. So here is an example of a pretty simple nested if statement. So this is like another college acceptance thing. So if our GPA is greater than 3.5, then we're checking if their SAT score is greater than 1,000, and if it is, we're accepting them to our college. If their int SAT score is not greater than 1,000, we want them to retake the SAT exam before we accept them. So this else goes back up to here. So if their GPA is not greater than 3.5, so if it's less than 3.5, then their SAT score has to be greater than 1,200. So if they don't have a high enough GPA, we want them to have a high SAT score. So if their SAT score is greater than 1,200, we accept them in probationary admission. Otherwise, we deny them admission. Okay, so one level of nesting inside the if statement and inside the else statement here. So question 2 for that you're going to have to answer in your Google Doc for this chapter is, what is a nested if statement in computer programming? So just explain to me what a nested if statement is. So that is question 2 that you need to answer for me. So we can also use if statements to check the value of a radio button, which you will be doing for a couple of examples in this chapter. So we say if the radio button lumber is checked. So you can say checked is equal true, but you don't have to. You can just say rad lumber checked. Then we do something. So we'll do a calculation and we'll set the value based on rad lumber. So here's another example. This is actually the code that you're going to be working on in this chapter for the guided program walkthrough. So we have here 2 levels of nesting. So we check if the decimal footage is is greater than 0. If it is greater than 0, so if it's not negative, we check the radio button. So if rad lumber is checked, we set the price per square foot for lumber. Then we do the same thing for redwood. So we have probably variables that we've set up above with the lumber cost, the redwood cost, and the composite cost. And then we have an else statement here. So we do something if that desk footage is greater than 0. So I'm assuming we probably display a message box, tell them to what they've entered, and display and tell them to enter a positive number. So just want to mention in here block level scope. So we talked a little bit about scope in the previous chapter when we created some class level variables for our applications. So we can have block level scope as well. So scope is defined by where the variable is declared within the program. So you can declare your variable to class level and it's available everywhere in your program. You can declare it in a procedure, so then it's available within that procedure, but you can also declare a variable within an if statement. So if I declare this variable dim int years inside this if statement, it is only available right here inside this if statement. It is not available in this else. It is not available below here or above here. It is only available right here inside this if statement. That is, in general, pretty bad practice to declare your variables inside an if statement, something I really encourage you to avoid. It's kind of why in the previous chapter we did all our variable declarations at the top, our assignments and conversions, our arithmetic, and then our output. So keep all your variable declarations all in one place so you know where all your variables are, because as our applications grow and get more complicated, it makes it a lot easier to find things if they're all in the same place. If you hide a variable declaration inside an if statement, and our applications we're working on in this chapter and in previous chapters have been pretty simple, but they are going to get more complicated, and we want to make things as easier for ourselves when we're debugging our programs and for other people that may be debugging our programs in the future. Okay, so you can declare variables inside an if statement, but I would encourage you to avoid doing that. So we also have logical operators that we can use with our if statements. So when one or more conditions included in an if then else statement, the conditions are called compound conditions. So a couple of the common compound conditions that we'll use are ands, ors, or nots. So we use an and, meaning all conditions tested in the if statement must be true, and or, one condition tested in the if statement must be true, or not to negate a condition. I'll explain what that means in the next slide. So the AND logical operator allows you to combine 2 or more conditions into a compound condition that can be tested with an if statement. So in this example, we say if flight cost is less than 300 and hotel cost is less than 1,200, then we do something. So we're combining here two different conditions into this statement. So both of these must be true in order for it to evaluate. So if one of them, if one of them is false, then the overall if statement gets evaluated to false with an AND logical operator. So the OR is kind of just the opposite. So what the OR logical operator is used to connect two or more conditions. The compound condition is true if any tested condition is true. So in this example, if the GPA is greater than 3.5 or SAT scores is greater than 1080, then we're accepting the student, otherwise not accepting the student. So if either of these are true, then the overall condition, if statement, gets evaluated to true. So that's the difference between our ands and our ors. And you may have some examples in the code to use this. So it's important to know that this is available and how to use them. And we have the not logical operator. So the not logical operator allows you to state conditions the way that are best expressed in a negative way. So this is kind of like when you take a test and they say, which of these things is not, and it's always confusing to people. I don't like using not logical operators. There's always a better way to write it than using not. So this is example. These two examples are the exact same thing. So we say, if not desk shoe size is greater than equal to 14. To me, that's very complicated. You can write that as if desk shoe size is less than 14. So these mean the same things. Which one is more easy to read? To me, the bottom one is much easier to read. If not desk shoe size greater than equal to 14, that it takes a little more of your brain power to figure out what's going on there. If you can write it this way, then do it. There are going to be some examples where a not operator does make sense, but usually you can get things done without a not operator. But there will be some examples, probably not in this chapter, but in future chapters, where a not logical operator might make sense for you. We have some other logical operators that you probably won't ever use. XOR is when one condition in the compound condition is true, but not both the compound condition is true. We have and alsos. As soon as a condition is found to be false, no further conditions are tested and the compound condition is false. And or else is as soon as a condition is found to be true, no further conditions are tested and the compound condition is true. So these two are kind of opposite of each other. These are for very specific complex scenarios that you probably, you may use someday in your career if you become a programmer, but probably not. There's probably better ways to use them, but they're there, they're available if you ever run into a complex scenario where you need to. It's good to know that these things exist, even if you never have to use them. And there's order of operations for these logical operators. Nots are always evaluated first. Then our ands and alsos, and then our ors, else, or elses, and XORs, or XORs. I've seen them pronounced both ways. I guess it's XOR. That's the way I like it. Hopefully you never have to use an XOR. So the last decision structure we're going to talk about is a case statement. So in some program applications, different operations can occur based on the value in a single field. So in this example, we're evaluating the number of the day of the week based on a number. So Monday is a 1, Tuesday is a 2, Wednesday is a 3. So the user enters a number and the program displays corresponding day name. So the code to do that on the next page is here. So we say select case int day number, and students usually kind of get a little confused with the way case statements are written. But what you're basically doing is getting that number into this case. So this int day number is going to have a 1 through 7 in it. So we say if this case int day number is 1, then we're displaying Monday. If it's 2, we're displaying Tuesday. If it's 3, we're displaying Wednesday. So you could do this with an if then else statement, but if you have just a simple list on one variable, it sometimes is a little cleaner to write. You are going to be doing one of your cases in this chapter where I want you to use a case statement, where you have to use a case statement for it. And it's written down in the assignment which one I want you to use a case statement. It really lends itself to a case statement, just so you have a little bit of exposure to it. So another example of using a case statement. So this case statement is based on the value in student text student major. So if that value in that text box is accounting, we're displaying business and department label text value. If it's marketing, we display business. Electrical engineering, we display engineering, and so far and so forth. And then at the end, we just have a case else. So if anything else other than accounting, marketing, electrical engineering, web design, e-commerce is in there, we just display other in that label. So can be a little cleaner than writing if statements. Case statements are definitely, you have less options with them. They're a lot less complex. So if you just have a simple list, you want to use case statements. If you have ands and ors and stuff like that, you don't want to use a case statement. You can use relational operators in a case statement, though. So in this example, we're looking at a range of values for the desk order amount. So if that desk order amount is greater than 500, we display a shipping cost. Greater than 40 or 400, we display a different shipping cost, and else there's no shipping costs. Okay. And in this example, we're saying if we're using a relational operator, it's not case equal to, it's case is greater than. So that's kind of something to be aware of if you're using relational operators. It's going to be case is, not just case greater than. And we can also use ranges in our case statement. So this is calculate a grade level. So select case in the grade level. So if the grade is 1 to 3, they're in elementary school. 4 to 6, it's late elementary. Grade is 7 to 8, middle school, and so on and so forth. So anything else, then it's an invalid grade level. So a little bit cleaner here. You could use greater than, an if statement to do this with greater thans and less thans. But I think this is a little cleaner. There'll be an example in one of your cases in chapter 5 where you're going to do something very similar to this. So you might want to refer back to the PowerPoint or the book to look at this example, because you'll be doing something very similar to what I'm showing in this example here in one of the cases. So the big decision is when to know when to use an if statement and when to use a case statement. So you might need to determine if you should use the select case statement or the if then else if statement to solve a problem. Generally, the select case statement is most useful when more than 2 or 3 variables must be tested for a given variable. The if then else statement is more flexible. So if more than one value could be used in a comparison, compound conditions with ands, ors, nots, operators can be used. So if then else is more flexible. If you just have a simple list of variables that you're comparing, no greater thans or equals, then you want to use a case. But most of the time, you're going to use an if then else statement. If it's a simple scenario with a bunch of values, 2 or 3 or more values, and you're not doing any ors and ands, use a case statement. Okay, and I'll give you which case in the chapter you want to use a case statement for, so you won't have to figure out that decision yet. You want to get more familiar with them before you start making those types of decisions. All right, so developers should anticipate that users will enter invalid data. Developers must write code that will prevent the invalid data from being used in the program to produce invalid output or an application errors and crashes. So the worst thing that can happen is your users are running your application, they do something, the application crashes, displays an error that the user doesn't understand and just closes. Users could lose work, they lose trust in the application, and that's bad. That's really bad if you're working for a company and your application is crashing without any explanation. What you need to do as a developer is anticipate what the user might enter incorrectly, and handle it elegantly. Display a message box to use it. Tell them what they did wrong. Don't allow that application to crash out. And that's hard to do. And we're going to be working on a couple methodologies for handling those errors in this chapter, but it's not going to capture everything. There's many ways to crash the applications. I know we're going to give you the guided program development gives you a couple ways to handle most of the errors. There are more errors than the guided program development as it's written in the chapter. That is not a bulletproof application. That is an application that is able to be crashed. But what I want you to do is try to crash your applications. And then try to see if you can come up with ways to prevent them from crashing them. When I test your applications, I will try to crash them. Okay, and I will probably be able to crash them. You will think you will think you have the best, most bulletproof application built, and then I'll enter something in there and it'll crash, and you'll go, "Oh, that was perfect." So an application that users cannot cause to crash is considered bulletproof. So no matter what the user does, what input they put in that text box, the application can't crash. Like I said, that's very difficult to do, especially the more complicated the application gets, the more difficult it is to prevent errors and crashes. So if you have just an application with one text box, probably pretty easy to prevent a user from crashing that application. If you've got 20 different text boxes, you have to write a lot of code to make sure every single text box they're entering the right kind of values in there. It gets complicated. And as we get through the chapter, we can write functions to do all that stuff. But it's hard to do. So our third question is, what is a bulletproof application? So what makes an application bulletproof? Okay, we just talked about that. I want you to tell me what a bulletproof application is. All right, the last thing we're going to talk about in this chapter is testing input to determine if the value is numeric. So the Visual Basic isNumeric function can check the input value to determine if the value can be converted to a numeric value such as integer or decimal data type. So in this example, you're going to do something just like this in your programs. So we say if is numeric. So if the value in text footage is numeric, then we do something. So if they've entered an actual numeric value in text footage, we know this is a good value and we can go on with our code. So we do all our logic in here. Else, so if this isn't numeric, then we want to do something. We want to display a message box to our user and tell them to enter the square footage of footing as a numeric value, okay? And then we clear out the value for them, and we put our cursor back on the text footage value so that they can re-enter that value. Okay, so in this example, we're checking if the text footage is numeric, then we convert the value in our text footage text box to desc footage. So in the previous chapter, we would convert this to a string first, but we know because of what we're doing here that it's a numeric value, so we don't have to convert it to a string first. We can just declare our variable as a decimal, okay? Because we know this value is a decimal, we know it's numeric. It might be an integer, but it could be entering it as decimal. So if we want our users to enter, they're not always buying 100 feet, they might be buying 100.5 feet. So we declare our variable here is decimal, converted to decimal. So then we check, so here we have 1, 2, 3 levels of nesting. We probably have another couple levels of nesting in here too. So then we check if the value, so first we check if it's numeric. If it's numeric, then we check if it's greater than 0, so we make sure that the number is not negative. And then we do our logic here, and we display our output. So a little more level of complexity in your applications here. So that's checking is numeric, is checking for a positive number. So again, entering a negative number is not going to cause the application to crash, but it's not valid. You can't buy negative feet of wood. So we want to make sure that the user isn't entering a a negative value in there. And we do that with our if statements and our is numeric function there. Okay? That's all I have for today. Make sure you answer those questions, and the next video will be the guided program walkthrough. Thanks.